Hello, the topic is Neural Networks Tool, Security of Intelligent Systems. My name is Pavel and I'm the PhD student at the Military University of Technology, and I want to introduce you to the beautiful world of AI, the neural networks, and all the performance that we are having right now. And these all deceiving things, adversarial attacks, all that kind of stuff is very exciting. Let's get started. So now we're going to go through some kind of a quick introduction to neural networks. What is AI? How it's working on a base structure helicopter view. Then we go through some capabilities of neural networks. We're gonna go through the heart of our intelligent nowadays intelligent super. Astonishing resulting networks. These are generative adversarial networks and their power, how they producing things and how good they are. Also going to go through some adversarial attacks and defenses against them, and my final thoughts, and the last slide would be questions. Okay, so without further ado, let's go and start with the definition of artificial intelligence. So artificial intelligence refers to the human simulation, to the simulation of human intelligence in machines. And when we're speaking about the artificial intelligence, most of the time we are touching at least one of those three areas: the learning, reasoning, or perception. And the learning is just about the not placing another if statement in our code. The machine learning algorithm would adapt to the new pattern, to the new behavior that has been observed. And the reasoning that we got some kind of a estimation, some kind of a threshold that we are passing, and then we have some kind of a decision upon that. And the perception is just gathering the data from the external source, like the image, like the sound, all that kind of stuff. And now the AI is so advanced that we're heading toward passing the Turing test. So which means that there's a one person behind the wall, there's other voice, and the human cannot detect is that the other voice is a human or the robot. So we're heading toward that, and we are pretty close. Maybe a couple of years I'm gonna be there. And artificial intelligence is around us. Like maybe you haven't noticed, but there are plenty of technologies that are now using the AI, like smart cars, drones in the cars for sure. Tesla is automating everything. The danger detection in Tesla is awesome. These smartphones like Google Assistant, Siri, face detection like Face ID or autofocus on the face in cameras. And in the newer technologies in phones, there are also the augmented reality. In social media, there's managing the content like in a proper way, like adjusting the content to the personality of the person that has an account, and also the advertising purposes. In the video games, this is really broad topic, and now the machine learning algorithms just crushing the professionals in one of the most complicated games like Dota, StarCraft, chess, and Go. And recently, DeepMind, after releasing AlphaZero that crushed everyone in chess, they published the Mu Zero, and they got the challenge that they're going to be learning the machine without knowing the rules. So it's a bit like everything, like every sequential algorithm involving human, of course. Okay, in the marketing, we get customer behavior analysis, chatbots, enhanced digital advertising, and banking and finances, we get effective decision making, process automation, and security and surveillance, some video tracking, analysis of strange behavior, and maybe even danger detection in some cameras. Yeah, so this is all around us, and this is caused mostly because the development of the neural network is complicated. Maybe not so super complicated, but complicated structures when it comes to these detections. And the neural networks is just a mathematical structure, like inspired by the biological neurons. And to get the basic overview of them, it's like we got the input layer on the left and the output layer on the right, and And this input layers on the left is just representing a numbers like height, amount, age, or nationality. And depending on the data that you're putting into the neural networks, is going to take a decision and take the decision after the classification. So really, when you're training on some kind of a junk data, you're going to have a junk results. So this is a really important to understand, because there's going to be like emphasized in the future slides, that this is a vector of attack. When you are changing one of those neurons, like the values of those neurons, you're going to have different results. And when you're manipulating in smart ways those neurons, you're going to have maybe some, you're going to have the attack, like the opportunities to attack. And on the output layer, we got the number. And this number is also means like maybe it can mean the probability of something or the estimated price of something. So it all comes down to your tuning of the neural network, and what you want to have, how to analyze the results on the output layers. And also, this is very important that the quality of prediction is dependent on the quality and distribution of the data. Also, usually amount of data also counts. Like the more data we have, the better, the more flexible model is and more accurate. But this is not always the case, but usually it applies there. So this is a basic neural networks. Between those, the input layer and the output layer, there are weights, and the weights are having some number that is multiplied by the previous neuron, like here the input layers multiplied by this arrow number that is learned through the process of learning algorithm optimization. And then we got some output based on that input and multiplied by this one. And as you can see, there are 12 of those arrows, because 3 times 4, that's 12. And we got 3 neurons, so there are 3 numbers, 12 here and 7 here. So that's 19 elements of the neural network. So this is a really, really basic neural network. Not complicated, not that easy to cheat. And we got some more complex neural networks that can solve some harder problems. We got a more abstract overview of more abstract understanding of what is going on those input layer. So this is a pretty complicated, but there are for sure more complicated, like convolutional neural networks, when we have more than 134 millions of elements in neural networks. This is a basic VGG16 model that was very, very popular. And after making an error on a level of 8% around on detecting 1,000 images, it became this computer vision system became very popular, and it's going with more development of this, we got pretty impressive results. And what are those impressive results? So first of all, some basic task that computer vision can do is a image classification, like we got a cat, so it's going to classify it as a cat. And for now, like for over 3 years, machines are better than humans in that. It might be surprising, but the level of error that human do on the 1,000 elements on the pictures, it's around 5%. And now on the 2018, there was a machine learning algorithm called ResNet that has 3.8% of the error. So one chunk of the image, and the machine learning algorithm is going to detect that, and human might not. The next is object detection. So now we're not only classifying but also localizing it. So that's also like now we get the position of the object, so we can react on some kind of way. Maybe we would want to have some kind of middle point and react on it. So maybe turn left, turn right. There are more possibilities to that, and yeah, this is still ongoing ongoing area of improvement. But let's jump to even harder ones. So image segmentation. So now we're going to classify every single pixel to the specific class. So the classification would look kind of like that when we are going to frame it in a way, and every pixel in this frame is going to be classified as here as an elephant and here as a giraffe. So every pixel here, and this is it goes down to like more of the understanding of the scene, and we can make more decision on that, and we can analyze what are the positions of those elephants, giraffes, and if they are nervous or that kind of stuff. So there's a lot more to it. And these are only 3 tasks, and there are many others tasks that our machine learning algorithms can do, like is solving right now. Maybe not solving, but have really good attempts to solve. So I've just listed some of them. There are hundreds of them, literally hundreds of them, and some. The ones like anomaly detection, music generation, sentiment analysis, object tracking. Subject tracking is on the surveillance cameras, like the camera is tracking the object that is like passing by, and maybe take some pictures. Image captioning, like describing what is in the picture. That's also complicated and requires to mix 2 models of NLP and the convolutional neural networks. Video or every machine translation. So there are many tasks, and the researchers are working really hard to make that in an even higher level. And now we're going to jump into some more advanced stuff. So this stuff that are cheating our minds and our all senses. I mean the generative networks. And the generative networks are based on a concept of mutual learning of networks. So there are 2 networks, discriminator and generator, and they're fighting with each other. Discriminator is going to detect if someone is producing fake images, and the generator want to cheat this discriminator if like producing the best images of the best replica of something that will cheat this generator, and he will approve that this is a legit video, legit music, sound, or the imagery. Okay, and now they are so good at this generative network that they can easily deceive human senses by producing astonishingly realistic results. And how they are working on a helicopter view. And so we got the discriminator right here, and the discriminator is just taking in an image. And he knows that because this is a trained network that was trained for several hours, and it was it's just can detect some maybe cats, dogs, and all that kind of things. But the more important is this generator network, and the generator networks have a d-dimensional noise vector that is passing through the generator network, and is applying the changes in this noise, and produces the fake images that are the same resolution as these real images. And the fake image is going to the discriminator, and discriminator looks at this and nah, what is that? This is a random crap. That's you did some big mistakes here. Like this is an error, and it's showing the number, and via the learning process, the generator is applying some fixes, some adjustments, and it goes on and on and on. And the process of learning is going to hit the limit when the generator is able to cheat the discriminators with some imagery that he has produced. And after that, we got some final predictions. Of course, this is a simplified explanation of the generative adversarial networks, and now those networks are really become more complicated, but also get some astonishingly results. Okay, so let's see. You can see now the young clay, probably 20 years old, the pretty nice, but as it turns out, she does not exist. Every sense is telling me that she exists, but this is generated image. She never have taken that, and she never have taken that picture. And it's getting a little bit creepy because the machine have produced that. And I'm watching this, and I'm sure that it's a person, maybe in real life, maybe even someone near my house. Okay. And so this is one of the applications. We can also enhance some quality of an image. So we got some blurry, wiggly, belly down the picture, from the from my mom, she's taking a picture, and let's click the picture, and the phone is shaky, and and now machine learning algorithms can fix, apply those changes, sharpen the lines, sharpen the textures, and it looks pretty, at least better than the previous one. And yes, we can progress from the 144 to pixels, the resolution, to the 4K. So it's becoming really, really nice. And when I don't know if you remember the old Britney Spears "Hit Me Baby One More Time," the music video. Yeah, so the fans of these generative super resolution GANs make it 4K music video. So that's pretty amazing. Okay, now next we got some voice cloning. So when you record 15 minutes of your voice, there are some solutions in machine learning that will almost identically copy your voice. And everything you type, it's going to be saying with your voice the words that are being typed. And actually, when you combine those those technologies, generation of the face, all those details, and enhancing every texture, and also copy the voice, then you get some pretty darn good technology. It's called deepfakes. I don't know, but this guy on the right is generated, and this guy on the left is a real one, and I don't see the difference. And this is a Tom Cruise. Okay, and the machine learning algorithms has been progressing for long, and this now the video what I'm saying is not a is not a real Tom Cruise, but it was the algorithm was learned from all of his videos, and knows his face. And now let's see, you have seen the image segmentation right there when the face was removed, and here also the image segmentation, the face and this is all blurred to black. Also here, and since we got the image segmentation, we can just take this face and place it in another person, and this is a real person on the left, but we have replaced the face with the Tom Cruise, and that's amazing. That's an amazing result, as you can see. Yep. Pretty creepy, but it's evolving pretty fast and is getting pretty good results. So it seems like a good performance from the machine learning side, right? It easily adjusts to trends and patterns. It has continuous improvement, it has continuous improvement, as something new comes up into picture, it just learns it because the pattern has changed. It solves complicated problems, as you can see. It can detect an image on some border, and in normal algorithms almost impossible. It has a faster inference, faster production. About the production, we get the I got an example from the Cosmos simulation. Recently I've read that some of the researchers have injected a generative adversarial network again to the simulation of the Cosmos, and it turns out the simulation of the Cosmos sped up to 900 times faster. So 900 times. We don't need supercomputers to calculate that. We only need to my machine, my laptop. I was astounded. Nice, really nice. But there is a reasonable that these technologies can improve outcomes and reduce costs. And in this slide, it's like unsurprising that dozens of private companies like healthcare have initiated an effort to deploy deep learning algorithms and classifiers. As such effort continues to develop, it seems inevitable that deep learning algorithms will become a common thing in the technology industry. However, the massive scale of areas like healthcare or automotive brings with it a significant opportunity and incentive for fraudulent behavior and potential harm. For example, when you get the Tesla driving, and you get the opposite, maybe some kind of a company that also is fighting for the first place in the electric cars and technology, and the second company will want to cheat the machine learning algorithms from the Tesla and add some attack on those systems, and now so that we got some potential benefits and the rise of the respect. And now we're heading toward the adversarial attacks. And in short, adversarial attacks are just using a neural network to cheat the other neural network. So one neural network is going to produce some kind of a result, and you can do everything with it. And now we want to cheat the another neural network. So in short, there is something that we want to cheat. There's an AI and we want to cheat it. Like, is that a horse? Is that a shark? It's a horse. Yeah, and so AI had some pretty hard time to detecting some things, and now we can have some division between attacks, and one of those is a training time attacks. It's called poisoning. And when you poison the in a training time, like before it was trained, you can poison the data set, and now the machine learning algorithms will gonna cause the bad classifications or some wrong understanding of the seed. Okay, we got some decision time attacks, and there are more. They need to be more creative. They are like more fun to watch, more fun to learn, but we get a harder time to defend against those ones. So we got the learned model, and now we want to cheat the learned model. Okay, how's that from the helicopter view? How's that looking? So we get the raw data and process data, and now on that data we can process some poisoning. So add some nasty pixels, add some chunks of the image that is not really that image, or like a filter the image, or add some noise to the sound or something like that. And on the right side, when the algorithm is learned, you see, so after the optimization process and all that kind of stuff, we got the we got the model, and now we can, on the decision time, when we got the image to detect, or we can apply the decision time attack. And the training time attack actually happened in 2016 on the Microsoft TI. So the Microsoft TI has been learning. It was a chatbot, and he was designed to be learning on the tweets of the people. And it turns out that the people, like nice dudes, they were starting to poison the learning chunk of the data for the Taya, and she has transformed from the kind teen to the racist and the Hitler fan. So that was pretty nice. I like it. Like funny and not funny at the same time. Okay, decision time attacks. Those types of attacks, as I said, that there are on the learned models, so the model is learned, and we are going to attack the robustness of the model. So the model maybe was learned for one distribution of the data, or maybe it was not flexible enough, and we can leverage that. So the first attack is the adversarial noise. So we're applying some kind of a changing in a pixel. It's called a noise. And for the human perspective, there's no change in a pixel in an image, but from the neural network perspective, it changes significantly. But this because it's processing the data from pixel point of view. So we're changing the input layer, like previously mentioned. We're changing the value that is added in, that is inputted into the neural networks, and so So the output also changes, and we can be very specific about the model that we are attacking. Like here on the second lane, we get the adversarial attack based on the adding some kind of portion of the image, and say some kind of I don't know, a chicken, bird or something was added to the picture. And the last lane we got these added details into the picture, and it turns out that on the one of the most popular model, VGG16, we can fool this classifier with a certainty of 93.9%. So this is a biggie, like, whoa. We can cheat it with just this chicken. Okay, we got also another model like VGG19, and also some kind of a bird on the right side, and we're cheating it with 95% almost. And also we can add maybe some random noise, and now you can probably should to like close your face to the screen to see what's the result, like what's the difference between those lower ones and the upper ones. And the that kind of a noise added to the picture is falling with the 93.9% in the Inception V3 model. So probably choosing a model is also a security concern. Yep. And the next one, we get the adversarial stickers. These are, in my opinion, one of the most dangerous things that are evolving right now. We can poison the image in the physical world, like you can place this disturbance, this noises, this stickers on the elements that need to be detected. And now, what you can see on the screen, the classifier wants to classify the stop sign, and it's designed for classifying it, but it failed because of this adversarial sticker that was placed on the top, on the bottom, and now it detects bottles. So that's from the automotive point of view and the smart cars, that's pretty significant, and to defend on that would be probably the crucial point of security. And about the real life examples, we can also attach it to the real person. Like also we got the element that was added, the noise that was added on the shirt or on a picture like that, and from the perspective of an intelligent machine, that person does not exist when he has that. Okay, so that's pretty significant. And what's the impact of those kind of attacks? And it turns out that the impacts are maybe huge. Like maybe we're going from the little impactees to the bigger ones. So let's go like like we're having some kind of a backpack, and we're gonna place to someone this adversarial sticker to the backpack, and now every machine learning like algorithm intelligent car, we're going to recognize that person from the back if it's not prepared to, if it's not learned from that kind of adversarial stickers. Maybe on the shirt was presented before as well, and maybe on the cars. Of course, we can place on the car, and there's a problem with the detection. Yeah, so this becomes like more problematic, and the automotive industry probably should take care of it and at least consider it. And not only automotive, but also other like surveillance security, or when some person is robbing a bank and the person just have adversarial sticker and just passing by. Hello, yeah. So that would be unfortunate. And now we got some serious attack. When you got the radio turned on, yeah, and you got your phone, like Google Assistant Siri in the phone, and it's logged in because that's your phone. And now from the radio you can hear some song, and then someone from the radio just is attacking the speech recognition system that you have in your phone. And from human perspective, there's like normal sound is going on, like like the Britney Spears songs, who cannot detect anything, but the machine learning algorithms is detecting this little changes in the neural network, and then you can execute some command from it, like I don't know, send some emails or phone someone or anything. You can like take a picture. You can even take a picture with the usage of the voice now in nowadays telephone. So that's it's pretty big when we have when you have also in home that kind of a system that is listening to your voice or to any voice and reacting on the comments on the comments, and yep, that needs to be addressed as well. So let's go to the defenses. And there are several defenses, but the area of defending against adversarial attacks is pretty new. The researchers have been focusing it from the 2019, so it's 2 years of development in that area, and since then, maybe not 2.5 years. And when you look into the papers, like research papers, you can see that like every day there are at least 2-5 papers that are released to the public. like every day. Every day there are some papers that are released. So these defense systems are the researchers are progressing with the defending of those attacks, adversarial attacks. And now let's go into the first defense from the attack. It's pretty basic one: secure the learning algorithms. And how I just mentioned on the specific model attack, when you have a very popular model in your production environments, really there are some high chances that you're going to fail. Because this model is well known, and the pixels that you can apply, there could be one person that is that one person that has cheated the neural networks in their home, just learning the model just like you have. So he can just apply the same noise to your machine learning model and on his, and he might be attacking you in that way. So probably learning your own model would be more secure, also restricting all the data that is coming out from the machine learning algorithm, so even the results of the detection. So you might be hiding them, probably. Even that information, securing all the models would be good. And also multiple classifier systems. So we got at least maybe at least 2 classifiers, but probably more. So and one classifier has been learned on other data, maybe applied some filters to the object, maybe or maybe decompose it, or maybe encode it in some way, and before getting into the machine learning algorithm, and then cheating the more classifiers, more than one classifiers at the same time, would be a really harder task to do. Because you need to have so many variables that you need to comprehend at the same time, and maybe not one basic algorithm would not it would be not sufficient time to crack into these neural networks. And at the end of those classifiers, you get so-called fuser, and the fuser is just it might be it's just making a decision upon if we want to classify it as it should be classified. And the fuser might be another machine learning algorithm, like another neural network that is that the input layer are the classifier results. and it's just going to be a anomaly detection when something is strange. It has postponed the detection, or doing something that we have told it to do. And another one is we can defend from this random noise by adversarial learning. And you got the paper here. You can just go into that paper: defense against adversarial attacks using feature scattering based adversarial training. And you get this random noise that is added to training set, and based on that you're learning also your algorithm, but you're applying the correct labels but with the noise. So now your model is more robust and more prepared for the noise. Another one is you can have people that are attacking your intelligence systems, and based on that detecting the failures like the testers do. And based on that, you can bring some mitigation steps, or even be aware of what will be cracked, and how we should proceed when something is cracked in the system. And the next one is the noise detection. So maybe in some systems we want to just see at the picture, and when you detect some noise, and then you can just stop the detection and say, no, we weren't going to detect that. And in some cases, this is possible, but in some cases, this is not. So maybe we can stop the detection like overall, or remove this noise and just apply the changes that we want to be applied. So yeah, there are several things that can be done here, but the major thing is that we're going to detect that noise and do something with it. Okay, and I'm heading toward the end of the presentation, and so yeah, that was all. And my last thoughts are to we are heading toward the area where computers can easily deceive human mind. And the only way to detect the fraud is to develop anti-fake detectors. And given that information, everything is becoming a little shaky from the perspective of human interaction via internet, because which video to trust and which wars are the real ones. With the greatness of the technology, there's a shadow of the hostile usage, and there's no law that will stop the development of new, more deceiving, more realistic, and more perfect machine learning algorithms. And I hope that along with the development of AI, security of it will be taken into consideration, because someday my life is going to depend on it, and then I would not want to adversarial stickers mess with my dinner plans. Yep, thank you. That was all from my presentation, and I'm listening to the questions. Let's go.